Okay, remember that I updated this assignment and we're only going to be showing the work for 1, 2, 3, 7, and 8. And that 7 and 8, I'd like you to use the factoring method and we'll discuss why. So in this first one, we technically could use the factoring method as well, but I'd like you to demonstrate complete the square method. So step 1, I move the 0 to the other side to make space for completing the square. I go off to the side to do the B work. Negative 2 divided by 2 squared is negative 1 squared is 1. We're going to be adding 1 and subtracting 1 from both sides. This makes the x minus 1 squared factors, and then 15 and 1 make 16. We're then going to add 16 to both sides. The whole reason we just made the perfect square factors is so that we can square root both sides. We're going to solve by square rooting. Moving up here, this makes plus or minus 4 is equal to x minus 1. We're now going to add 1 to both sides and get 1 plus or minus 4. Well, this is two real roots where I'm going to separate them out right now. 1 plus 4 is 5, and 1 minus 4 is negative 3. So my two real roots are negative 3 and 5. I could have done this by factoring method at the beginning and gotten the 3 and 5 and solved. Next, we're going to take this one, but it's not in standard form yet. We need to minus the 35 from both sides. Now that it's in standard form equal to 0, we can apply all the same steps that we're used to. Step 1, make space. Step 2, B work. Add 1 and subtract 1 from both sides. This makes the x plus 1 squared factors, and this is a minus 36 at the back. We add 36 to both sides. Now that we've got it in this format, we can square root both sides. So moving up here, I'm going to get plus or minus 6 from the left, and the x plus 1 comes out. I then subtract 1 from both sides, and I can now start to see my two real roots. The first one is negative 1 plus 6, and the second one is negative 1 minus 6. My two real roots should be 5 and negative 7. Yes, I could have solved this by factoring the whole time. We're just demonstrating the two different methods so we can have a discussion about that. Finally, this next one is also not in standard form. So we're going to add 2. Oops, let's put this in the right place. Underneath, we get 2x squared plus 8x minus 5 equals 0. So on this one right here, 2 parentheses, we're dividing out of 2. We're left with x squared plus 4x. And then the minus 5 to make space, I'm going to put the 0 equals in front. So I moved the 0 to the front to make space. I divided out the 2 from the front two terms, here and here. Now I have to go divide again for the b work. The b is a 4. 4 divided by 2 is 2. 2 squared is 4. I'm going to be adding 4 and subtracting 4 2 times. Now I get 0 equals 2 times the quantity x plus 2 squared minus 13. I add 13 to both sides. I get 13 equals 2 x plus 2 squared perfect factors. I'm now going to divide both sides by 13. Let me change colors here. Sorry, divide both sides by 2. So 13 halves is equal to x plus 2 squared. I'm now in a position to be able to square root both sides, and plus or minus root 13 over plus or minus 2, and then finally we subtract 2 from both sides. Negative 2 plus or minus root 13 over root 2. Well, we've never gotten a square root in the denominator like that before, and we're not allowed to leave it. So we do something called rationalizing the denominator, where we multiply by that denominator, root 2 times root 2 in the denominator. That's going to solve my problem by giving me a root 4 or just a plain 2. In the numerator, that makes root 26. And now we're done. Here's my 2 real roots because the discriminant is positive. The new thing here that I haven't gone over yet is this rationalizing the denominator step. We'll talk about that. I'm going to do number 5 as well. Same thing here where we need to minus 6 from both sides to get it ready. Now it's in standard form. So step 1, make space, dividing out the 2, and bumping that -1 over when we make space. We're now going to do the b work on this new b. -2 divided by 2 is 2 squared or -1 squared, which is just 1, and minusing 1 2 times. This makes the 2x squared minus 1 factors, and then -1 minus 2 is going to eventually make 3. We're going to add 3 to both sides, and we're left with 3 equals 2 quantity x minus 1 squared. And here we go again with this 3 halves equal to this, so that when I go square root both sides, I'm left with square root of 3 over square root of 2. So we're going to add 1 to both sides and get x equals 1 plus or minus root 3 over root 2. But I just told you guys that we can't have a root 2 in the denominator. So we're going to rationalize the denominator, which leaves me in the top root 6, in the bottom just a 2. Root 2 times root 2 makes root 4. Square root of 4 is just 2. Here's my 2 real roots with that positive discriminant after rationalizing the denominator. All right, these bottom 2, I asked you to do them, but with the factoring method. What times what makes 8? And subtracts to give us positive 2. Now that they're equal to 0, I can set each factor equal to 0 with the 0 product property. So I could have solved this one with complete the square, but you see how quick the factoring method is? So the point of this worksheet is to understand that there is an efficient time to use complete the square, and there are definitely efficient times to use our other methods. So the point of this worksheet is to struggle with complete the square, some more than others. And after we struggle with it, we go, you know, I really should have used the factoring method on this. Or this complete the square was pretty bad. I probably should have just used the formula. So my 2 real roots are 9 and -2. My 2 real roots over here were -4 and 2. So originally assigned the whole worksheet, saw how bad some of these were. So now I've gone ahead and lowered the number of problems you need to complete for credit. If you could at least do these ones on the front for credit and turn it in, just the front side. I am going to post a full key of the back ones as well for people who tried those. They were definitely more challenging. Thank you.